September 19th, 1944, 06:15 hours, near Arracourt, eastern France. The morning mist clung to the Lorraine countryside like a shroud, concealing the advancing steel behemoths of the 113th Panzer Brigade. Colonel Erich Feuchtinger, a veteran of the Eastern Front, who had witnessed the mechanized carnage at Kursk, felt confident in his Panther's superiority. His brigade possessed 42 of Germany's finest tanks, Panzer III Panthers, with their legendary 75mm KWK, 42 guns, and frontal armor thick enough to deflect most Allied shells. At precisely 6:20 hours, the morning silence shattered. Through the fog came a sound that defied every expectation of armored warfare, a high-pitched mechanical whine, almost musical in its intensity. It resembled an aircraft engine more than any tracked vehicle the Germans had encountered. Then came the muzzle flashes, orange tongues of flame erupting from invisible positions, followed immediately by the distinctive crack of 76mm guns firing in rapid succession. 3 Panthers died within 5 minutes. What terrorized the German crews wasn't just the speed of destruction, but the impossibility of retaliation. By the time their massive turrets traversed toward the enemy positions, they found only empty ground and dissipating smoke. The attackers had vanished like ghosts, leaving behind only the burning hulks of Germany's most advanced tanks. Oberfeldwebel Hans Krüger, commanding a Panther in the brigade's lead company, would later describe the encounter in his post-battle report. The enemy vehicles appeared to float across the battlefield. No tracked vehicle should move with such velocity. We assumed they were wheeled tank destroyers until our intelligence officers examined the track marks. The realization that these were tracked vehicles moving at highway speeds shattered our understanding of armored combat. The M18 Hellcat's genesis traced back to a classified briefing room in Washington, D.C., where Lieutenant Colonel Andrew Davis, Bruce stood before a gathering of military planners in December 1941. The devastating efficiency of German blitzkrieg tactics had rendered obsolete virtually every assumption about modern warfare. Poland's collapse in 35 days, France's capitulation in 6 weeks despite possessing the world's largest army. These disasters demanded revolutionary thinking. Bruce, a cavalry officer who understood that mobility could triumph over static defense, proposed something unprecedented. Instead of matching German armor thickness for thickness, gun caliber for gun caliber, America would build hunters that pursued, tanks with the same relentless speed that cavalry had once pursued infantry. The concept violated every principle of contemporary tank destroyer doctrine. Traditional thinking emphasized heavy armor, powerful guns, and defensive positioning. The German Jagdpanzer series embodied this philosophy. The Jagdpanzer IV weighed 25 tons with 80mm frontal armor, while the massive Jagdtiger tipped the scales at 71 tons with armor up to 250mm thick. Bruce's vision was radical: create a vehicle so fast that it didn't need armor, so agile that enemy guns couldn't track it, so mobile that it could strike anywhere on the battlefield before enemy commanders could react. The technical challenges were staggering. No tracked vehicle had ever sustained speeds above 40 miles per hour cross-country. The physics seemed prohibitive. The faster a tank moved, the more it needed suspension travel to handle terrain irregularities. More suspension meant more weight. More weight meant more powerful engines. More powerful engines meant larger fuel consumption and mechanical complexity. American engineers at Buick's Detroit facility attacked the problem with characteristic industrial innovation. Chief Engineer Joseph Colton assembled a team that included aircraft engine specialists, automotive transmission experts, and suspension designers from the racing industry. Their approach was revolutionary. Instead of scaling up existing tank technology, they would create something entirely new. The breakthrough came with the Wright R975 Cyclone engine, a 9-cylinder air-cooled radial originally designed for aircraft. This power plant generated 400 horsepower while weighing significantly less than conventional tank engines. The air cooling eliminated vulnerable radiator systems that enemy fire could easily damage. The radial configuration provided exceptional power-to-weight ratios, 22.6 horsepower per ton compared to the Panther's 15.6 or the Tiger's dismal 12.8, but power alone wouldn't achieve the required speeds. The transmission proved equally crucial. General Motors developed the revolutionary Torque-O-Matic system, an automatic transmission with 3 forward speeds that shifted based on load and velocity. This eliminated the complex clutching required in manual transmissions, allowing drivers to concentrate entirely on maneuvering at high speeds. The suspension system represented another breakthrough. Torsion bar suspension with 14 inches of wheel travel absorbed impacts that would have shattered leaf spring systems. Each road wheel could independently navigate obstacles while maintaining tire contact with the ground, crucial for high-speed stability. German intelligence services, despite their reputation for thoroughness, completely misread American tank destroyer development. Oberst Heinrich Müller, Chief of Wehrmacht Technical Intelligence, filed a report in early 1943 dismissing American designs as typical Anglo-Saxon mechanical obsession without tactical understanding. German doctrine, proven through 4 years of successful combat, emphasized that effective tank destroyers required massive armor protection and powerful guns. Their own Panzer Jäger series mounted 88mm guns on heavily armored chassis. The concept of a 17.7-ton vehicle with armor thinner than many armored cars seemed militarily absurd. This intelligence failure stemmed from cultural blindness. German engineering traditionally prioritized quality over quantity, precision over adaptability. The idea that Americans would intentionally design vulnerable vehicles violated Germanic military philosophy. When early reports mentioned American tank destroyers capable of highway speeds, German analysts dismissed them as reconnaissance vehicles, misidentified by combat-stressed crews. Major General Friedrich von Mellenthin, intelligence officer for Army Group Center, later admitted, "We consistently underestimated American industrial innovation. We assumed their tank destroyers would follow conventional patterns because that's how we would have designed them." This assumption cost us thousands of tanks. May 23, 1944, marked the M18's combat debut during the Anzio breakout. The Hermann Göring Panzer Division, one of Germany's elite formations, encountered something unprecedented during fighting around Cisterna. Their daily combat report to the 14th Panzer Corps recorded, "Enemy employs new tank destroyer type. Vehicle speed estimated 70 to 80 kilometers per hour. 2 Panzer IVs destroyed before enemy vehicle withdrew. Return fire ineffective due to target's rapid movement." Hauptmann Wolfgang Schneider commanded the lead company that first encountered M18s. His post-action report provided chilling details. "The enemy vehicle appeared on our left flank at approximately 0730 hours. It fired 3 rounds in rapid succession, destroying Weber's and Hoffmann's Panzer IVs. Our turret traversed to engage, but the target had already displaced approximately 300 meters. By the time we acquired the new position, it had fired again and moved. Total engagement time, less than 60 seconds. The psychological impact proved as devastating as the physical destruction. German tank crews had operated with virtual impunity against most Allied armor. Sherman tanks, though numerous, posed manageable threats. British Churchills were heavily armored but slow. The M18 represented something entirely different. A predator that hunted German armor with the same ruthless efficiency that German tanks had once demonstrated against Allied forces. September 1944 brought the full revelation of the M18's capabilities. Hitler had personally ordered a counter-offensive to recapture Nancy and destroy Patton's spearhead. The 5th Panzer Army under General Hasso von Manteuffel assembled its finest available units. The newly formed 111th and 113th Panzer Brigades, equipped with factory-fresh Panthers straight from the production lines. The 704th Tank Destroyer Battalion, attached to the 4th Armored Division's Combat Command A, had positioned their M18s in concealed positions around Arracourt. Lieutenant Edwin Leiper's platoon exemplified the new tactical doctrine. Instead of static defensive positions, they had prepared multiple firing positions connected by concealed routes that allowed rapid displacement. As German armor advanced through the morning fog, Leiper's 4 M18s struck with surgical precision. Sergeant Henry R. Hartmann's crew achieved extraordinary success, knocking out 6 Panthers in rapid succession. Each engagement followed the same pattern. Fire 3 to 5 rounds from concealment, immediately displace 200 to 400 yards, re-engage from a completely different angle. The German response proved tragically inadequate. Panther crews, trained for methodical long-range engagements, couldn't adapt to enemies who refused conventional tank duels. Their sophisticated fire control systems, designed for precision shooting at stationary targets, were useless against rapidly moving opponents who appeared, fired, and vanished within seconds. Colonel Feuchtinger's after-action report painted a picture of tactical helplessness. Enemy tank destroyers demonstrated unprecedented mobility, estimated speed 80+ kilometers per hour. Our return fire consistently missed due to targets' rapid displacement. Conventional engagement procedures proved ineffective. The 113th Panzer Brigade suffered catastrophic losses, 39 tanks destroyed, 11 damaged. American losses, 3 M18. When German forces finally captured an intact M18 near Metz in November 1944, Wehrmacht weapons testing officers conducted exhaustive examinations. Their technical report, forwarded to the Inspector General of Panzer Forces, revealed specifications that challenged every assumption about armored vehicle design. The captured vehicle's specifications stunned German engineers. Weight, 17.7 metric tons versus Panther's 44.8 tons, less than 40% of the German tank's mass while carrying equivalent firepower. Speed, verified maximum velocity of 88.5 kilometers per hour on roads, 42 kilometers per hour cross-country. By comparison, the Panther managed 46 kilometers per hour maximum on roads, often much less in combat conditions. Power-to-weight ratio. The Wright R975C4 engine generated 400 horsepower, creating a power-to-weight ratio of 22.6 horsepower per ton. The Panther's Maybach HL230P30 managed only 15.6 horsepower per ton, while the Tiger I's ratio dropped to a pathetic 12.8. Turret traverse. The hydraulic traverse system maintained 15 degrees per second, regardless of engine speed or vehicle movement. German manual systems varied dramatically with engine RPM, creating tactical vulnerabilities. Most remarkably, the automatic transmission eliminated driver fatigue and coordination errors during high-speed maneuvering. German tank drivers required years of training to smoothly shift manual transmissions while maintaining combat effectiveness. The M18's Torque-O-Matic system allowed drivers to concentrate entirely on navigation and tactical positioning. Major Klaus Weber, chief of the testing commission, concluded, "This vehicle represents a completely different design philosophy. Every component prioritizes mobility over protection. The result is a weapon system that negates our tactical advantages through superior maneuverability." The M18's advantage wasn't merely psychological, it was mathematical. German turret traverse speeds, dependent on engine RPM, created predictable vulnerabilities. Tiger FAO, 6 to 19 degrees per second, requiring 19 to 60 seconds for complete rotation. Panther, early models, 6 degrees per second, requiring 60 seconds for full. Traverse Panther, late models, up to 19 degrees per second at 2000 RPM, minimum 19 seconds. Tiger II, 15 to 24 degrees per second, requiring 15 to 24 seconds. The M18's hydraulic system maintained consistent 15 degrees per second traverse, regardless of engine speed, critical when engaging multiple targets or tracking fast-moving enemies. At maximum speed, an M18 could cover 400 meters in 16 seconds, 800 meters in 33 seconds, or cross a 1,000-meter killing field in 41 seconds. A Panther needed 30 to 60 seconds merely to complete a 180-degree turret traverse while tracking a moving target at varying speeds. These mathematics created tactical impossibilities for German crews. By the time they detected an M18, acquired the target, traversed their turret, and aimed their gun, the American tank destroyer had often fired, relocated, and prepared for a second engagement. The 704th Tank Destroyer Battalion's combat manual, updated after Arracourt, codified new tactical doctrine: fire 3 to 5 rounds from concealed position, immediately displace minimum 200 yards, re-engage from new position at different angle, never remain stationary longer than 60 seconds under enemy observation. This shoot-and-scoot doctrine revolutionized anti-tank warfare. Traditional tactics emphasized static defensive positions where tank destroyers would engage approaching armor from prepared positions. The M18's mobility allowed dynamic defense. Tank destroyers could now hunt enemy armor across the battlefield. Staff Sergeant Carl Morrison, 705th Tank Destroyer Battalion, described the psychological transformation. "We went from being sitting ducks, waiting for German tanks, to being sharks hunting in their own waters. The speed changed everything. We weren't victims anymore. We were predators." December 19, 1944, provided the ultimate test of M18 capabilities. Hitler's Ardennes offensive, his final gamble to split the Allied armies, entered its third day. The 2nd Panzer Division, spearheading the drive toward Antwerp, approached the crucial crossroads at Neuville, defended by Team de Sobry and elements of the 101st Airborne Division. 4 M18s from the 609th and 705th Tank Destroyer Battalions faced overwhelming odds. An entire Panzer Division equipped with Panthers, Tiger IIs, and supporting infantry. The morning fog that had concealed German movements now became the Hellcat's ally. Technical Sergeant Robert Chen commanded one of the 4 M18. His crew developed tactics that exploited both the vehicle's speed and the weather conditions. They would fire 2 or 3 rounds, then reverse at maximum speed into the fog. By the time German tanks traversed their turrets toward the muzzle flashes, Chen's M18 had relocated 200 to 300 yards and was engaging from a completely different direction. The 705th Tank Destroyer Battalion's combat report documented extraordinary results. 4 M18s engaged elements of 2nd Panzer Division in fog conditions. Using high-speed displacement between firing positions, created impression of larger defensive force. Confirmed destroyed 24 enemy tanks. M18 losses: 1 vehicle to artillery fire. The 2nd Panzer Division's war diary recorded their frustration. Encountered strong tank destroyer resistance at Neuville. Enemy vehicles of high mobility operating in fog, unable to effectively engage due to rapid displacement of targets. Attack suspended pending reinforcement. This 48-hour delay proved strategically critical, allowing the 101st Airborne to strengthen Bastonia's defenses and ultimately hold the vital crossroads that became the hinge of the entire German offensive. By November 1944, German commanders desperately sought effective countermeasures to the M18 threat. General Hasso von Manteuffel issued tactical guidance to 5th Panzer Army. Enemy M18 tank destroyers confirmed capable of 80+ kilometers per hour. Hour road speed, 40+ cross-country. Standard engagement procedures must be modified. Do not attempt to track moving M18 with turret traverse pre-positioned turrets on likely displacement routes. Employ infantry with Panzerfausts on flanks. Use artillery to suppress suspected positions. Avoid pursuit. M18s will always outrun our vehicles. These adaptations proved largely ineffective. The M18's speed advantage was simply too great, and German crews couldn't overcome years of training, emphasizing deliberate, precise gunnery over rapid response. Oberst Hans von Luck, commanding the 21st Panzer Regiment, attempted innovative countermeasures. "We tried positioning multiple tanks to cover each other's blind spots, coordinating artillery with tank movements, even using aircraft for reconnaissance. Nothing worked consistently. The Americans had created something that negated our tactical advantages through pure speed." The Buick Motor Division manufactured 2,507 M18s between July 1943 and October 1944, with production peaking at 267 units in November 1943. Each vehicle cost $55,230. Expensive due to specialized components, but still mass-producible using automotive industry techniques. By contrast, a German Panther cost approximately 117,100 Reichsmarks and required significantly more production time due to complex final drives and transmission systems. The M18's design emphasized mass production from conception. The Wright R975 engine was already in production for aircraft. The Torque-O-Matic transmission used automotive components, and the open-topped turret simplified manufacturing. American industrial capacity proved decisive. While German factories struggled to replace combat losses, American plants produced M18AS faster than crews could be trained to operate them. This industrial advantage complemented the vehicle's tactical superiority. The Tank Destroyer Training Center at Camp Hood, Texas, developed specialized programs emphasizing skills radically different from conventional tank operations. Driver training focused on high-speed maneuvering, rapid acceleration and braking, and terrain exploitation. Drivers learned to maintain maximum speed while providing stable gun platforms during brief halts. Unlike German tank drivers who trained for methodical movement between firing positions, M18 drivers learned to think like race car drivers. Gunner training emphasized rapid target acquisition and firing on the move. M18 gunners learned to fire quickly at moderate ranges, accepting lower first-round hit probability in exchange for rapid engagement. This contrasted sharply with German training, emphasizing deliberate, precise long-range shots. Commander training stressed battlefield awareness, rapid decision-making, and coordination with other M18. Commanders learned to think 3 moves ahead, always planning their next 2 firing positions before engaging current targets. The psychological profile for M18 crews differed dramatically from heavy tank crews. Recruiters sought men comfortable with risk, able to make instant decisions under pressure, and who preferred agility over the psychological comfort of heavy armor. The M18's greatest weakness was obvious to every crew member: paper-thin armor offering minimal protection. With maximum 25mm protection on the turret front and just 13mm on hull sides, the vehicle was vulnerable to virtually every German anti-tank weapon. This vulnerability shaped every aspect of M18 employment. Never remain stationary under enemy observation. Avoid urban combat where speed is negated. Maintain minimum 500-meter standoff from enemy infantry. Use terrain masking continuously. Coordinate with infantry to suppress enemy anti-tank weapons. Despite this vulnerability, M18 crews achieved a remarkable 73% survival rate when their vehicles were destroyed. The high crew survival rate reflected the vehicle's primary defense. Speed allowed crews to escape even when their M18 was hit. Private First Class Michael O'Brien, 85th Tank Destroyer Battalion, described the constant tension. Every morning climbing into that tin can, you knew you were gambling with death. But it was a tin can that could outrun anything the Germans had. That speed saved my life more times than any armor could have. By war's end, M18-equipped tank destroyer battalions compiled impressive combat records. 704th Tank Destroyer Battalion, 106 confirmed enemy tank kills 603rd Tank Destroyer Battalion, 92 confirmed kills 69th Tank Destroyer Battalion, 67 confirmed kills 705th Tank Destroyer Battalion, 89 confirmed kills 85th Tank Destroyer Battalion, 51 confirmed kills overall M18 statistics, total vehicles in combat, 540, maximum strength March, 1945. Combat losses, 216 vehicles. Kill-to-loss ratio, 2.3 to 1 in European theatre average engagement range, 650 meters average engagement duration, 2.3 minutes. While respectable, these statistics revealed limitations in the original tank destroyer. Doctrine. M18s spent approximately 70% of their combat time in infantry support roles rather than hunting tanks. The doctrine's fundamental assumption of massed enemy armor attacks proved largely incorrect, as German forces increasingly adopted defensive tactics. The M18's combat success profoundly influenced post-war armored vehicle development worldwide. While the tank destroyer doctrine was abandoned and the tank destroyer force disbanded in November 1945, the Hellcat's demonstration that mobility could substitute for armor resonated globally. Soviet Union developed the PT-76 light amphibious tank and later BMP infantry fighting vehicles, emphasizing mobility over protection. Britain created the CVRT Combat Vehicle Reconnaissance Tracked series, prioritizing speed for reconnaissance roles. France built the AMX-13 with an automatic loader to reduce weight while maintaining firepower. West Germany designed the Leopard 1 main battle tank, abandoning heavy armor for mobility, a complete reversal of World War II philosophy. Modern wheeled tank destroyers like the Italian Centauro, Japanese Type 16, and American M1128 mobile gun system represent the M18's conceptual descendants, accepting vulnerability for strategic and tactical mobility. German forces, renowned for tactical flexibility and innovation, proved surprisingly unable to develop effective countermeasures against the M18. Several factors contributed to this failure. Doctrinal rigidity. German tank training emphasized deliberate long-range gunnery. Crews spent years perfecting precision shooting techniques that proved useless against rapidly displacing targets. Retraining experienced crews proved nearly impossible under combat conditions. Technical limitations. German turret traverse systems, dependent on engine RPM, couldn't match the M18's consistent hydraulic traverse. At idle or low engine speeds, German tanks were virtually helpless against flanking M18. Communication breakdown. German tactical radio systems, already stressed by Allied electronic warfare, couldn't coordinate rapid responses to M18 platoons operating across wide frontages. Psychological shock. The sudden transformation from predator to prey created psychological trauma among German tank crews that no amount of training could quickly overcome. Industrial constraints. Germany lacked the industrial capacity to develop and produce new vehicles specifically designed to counter the M18 threat. Post-war interviews with M18 veterans consistently emphasized speed as their primary survival tool. Staff Sergeant Vernon Miller, 85th Tank Destroyer Battalion. We lived by 3 rules: shoot fast, move fast, think fast. If you did all 3, you went home. If you failed at any one, you didn't. The Germans never understood that we weren't trying to fight fair. We were trying to win. Technical Sergeant John Patterson, 603rd Tank Destroyer Battalion. The Hellcat wasn't about fair fights. It was about unfair fights in our favor. We'd hit them where they didn't expect, when they didn't expect, and be gone before they knew what happened. That's not cowardice, that's tactics. Lieutenant Robert Chen, 704th Tank Destroyer Battalion. Every time I climbed into our M18, I knew I was sitting in a tin can. But it was a tin can that could run 55 miles per hour. That speed saved my life more times than any armor ever could have. Sergeant Henry Hartmann, 704th Tank Destroyer Battalion. The Germans fought like gentlemen. They lined up their tanks, took careful aim, fired deliberately. We fought like street fighters, hit and run, never give them a fair shot. War isn't about being sporting. It's about going home alive. The M18 incorporated several revolutionary features that influenced decades of subsequent vehicle development. Torque-o-matic transmission. This fully automatic transmission eliminated manual clutching, allowing drivers to concentrate entirely on maneuvering. 3 forward speeds shifted automatically based on vehicle speed and load conditions. Critical for high-speed tactical operations. Torsion bar suspension. Providing 14 inches of wheel travel, this system allowed sustained high-speed movement over rough terrain. Long suspension travel absorbed impacts that would have damaged traditional leaf spring systems. Wright R975 radial engine. This 9-cylinder air-cooled power plant provided exceptional power-to-weight ratios while eliminating vulnerable radiator and coolant systems. Air cooling proved particularly valuable in combat conditions where radiator damage could immobilize vehicles. Hydraulic turret traverse. Powered by an electric motor driving a hydraulic pump, this system provided consistent 15 degrees per second traverse, regardless of engine speed or vehicle movement. A critical advantage over German manual systems. The 637th Tank Destroyer Battalion brought M18 to the Pacific Theater during the Philippines campaign. Against minimal Japanese armor, the vehicles served primarily in bunker busting and infantry support roles. The open turret, advantageous in European operations, proved nearly fatal against Japanese infiltration tactics. Crews developed field modifications, including improvised overhead covers and chicken wire screens to defend against grenades and satchel charges. The vehicle's speed allowed rapid response to Japanese infiltration attempts, but jungle terrain often negated mobility advantages. Sergeant James Tanaka, 637th Tank Destroyer Battalion, described Pacific operations. In Europe, speed was life. In the Pacific, it was different. The jungle ate speed for breakfast. But when we could use it, moving between strongpoints, responding to breakthroughs, nothing the Japanese had could catch us. The M18's revolutionary performance required significant engineering compromises. The lightweight construction that enabled high speeds also created maintenance challenges. The torsion bar suspension, while providing excellent mobility, required precise adjustment and frequent maintenance. The Wright radial engine, borrowed from aircraft applications, demanded high-octane aviation fuel and specialized maintenance procedures. Many M18 crews became expert mechanics by necessity, learning to perform field repairs that kept their vehicles operational. Chief Warrant Officer William Rodriguez, 85th Tank Destroyer Battalion Maintenance Officer, explained, "The M18 was like a race car, incredible performance when everything worked perfectly, but it demanded constant attention. We kept them running through mechanical ingenuity and spare parts scrounged from anywhere we could find them." The M18 Hellcat embodied American industrial philosophy: mass production, standardization, and mechanical reliability over individual craftsmanship, while German vehicles emphasized precision manufacturing and complex engineering. American designs prioritized maintenance simplicity and production efficiency. This philosophical difference proved strategically decisive. German factories produced superior individual vehicles that required skilled technicians for maintenance and repair. American factories produced good vehicles that average mechanics could maintain in field conditions. The M18's automotive-derived components meant that crew members with civilian automotive experience could perform many repairs. German tanks required specialized training for maintenance personnel, creating logistical vulnerabilities that American forces exploited. Beyond mechanical innovation, the M18 represented a psychological revolution in armored warfare. For the first time in the war, German tank crews faced an opponent that refused conventional engagement rules. The Hellcat's hit-and-run tactics created psychological stress that no amount of armor protection could alleviate. German tank ace Hauptmann Michael Wittmann, before his death in August 1944, wrote to his family, "The Americans have created something we don't understand. Their tank destroyers fight like ghosts. They appear, strike, and vanish. Our training never prepared us for enemies who won't stand and fight." This psychological impact extended beyond individual engagements. German commanders found their tactical planning complicated by opponents who could rapidly redeploy across the battlefield. Traditional defensive concepts, assuming predictable enemy movement patterns, became obsolete when facing M18 units. The M18 Hellcat stands as one of World War II's most innovative combat vehicles, proving that technological superiority doesn't require matching enemy capabilities. It requires negating them. German tankers, trained to dominate through superior armor and firepower, discovered that American innovation meant changing the rules of engagement entirely. The Hellcat's 55 miles per hour top speed wasn't merely a technical specification. It was a paradigm shift that German tactical doctrine couldn't accommodate. The M18 proved that in warfare, as in nature, survival doesn't always favor the strongest or most heavily armed. Sometimes it favors the fastest, the most agile, the most adaptable. Today, when military historians analyze the M18 Hellcat, they see more than a successful tank destroyer. They see American military innovation at its most creative, identifying enemy strengths and systematically negating them through unconventional means. The German tankers never knew the American Hellcat could reach such speeds until they faced it in combat. That technological surprise, combined with tactical innovation and crew training, created a weapon system that transcended its mechanical specifications to become a symbol of American industrial ingenuity and strategic thinking. At 55 miles per hour, the M18 Hellcat didn't just outrun German tanks, it outran German military doctrine itself, proving that sometimes the best armor is simply not being where the enemy shoots. Weather conditions played a crucial role in M18 effectiveness, often determining the success or failure of engagements. The vehicle's low ground pressure, just 10.5 psi, lighter than many trucks, allowed operation in conditions that immobilized heavier German vehicles. During the Battle of the Bulge, Technical Sergeant Robert Kowalski, 823rd Tank Destroyer Battalion, encountered German armor in deep snow conditions. The Panthers were struggling through 2 feet of snow, their tracks spinning, engines overheating. From the strain, our M18 skimmed across the surface like it was pavement. We destroyed 4 tanks before they could even get their guns trained on us. The M18's air-cooled engine proved particularly advantageous in winter conditions. While German liquid-cooled engines required lengthy warm-up procedures and were vulnerable to freezing, the right radial started quickly in sub-zero temperatures and maintained consistent power output. Rain and mud created different advantages. The M18's wide tracks and low ground pressure prevented the deep rutting that trapped heavier vehicles. During the Normandy campaign's rainy season, M18 units consistently maintained mobility, while German armor struggled with mechanical breakdowns caused by mud infiltration into complex drive systems. M18 crews developed sophisticated camouflage techniques that exploited their vehicles' low profile and high mobility. The open-top turret, initially seen as a vulnerability, actually aided concealment by eliminating the distinctive silhouette of closed turrets. Sergeant First Class Antonio Martinez, 827th Tank Destroyer Battalion, perfected camouflage techniques during the Italian campaign. We learned to use shadows, terrain features, even smoke from burning buildings. The M18 was small enough to hide behind hedgerows that would never conceal a Sherman. We'd paint the vehicle to match local terrain. Olive drab in forests, tan and brown in desert conditions, even white in winter. The vehicle's speed allowed rapid movement between prepared camouflaged positions. Crews would spend days preparing multiple firing positions, complete with concealed approach routes and emergency escape paths. This preparation paid dividends when German armor appeared. M18AS could engage from one position, disappear, and re-emerge from a completely unexpected direction. The M18's effectiveness depended heavily on superior American radio communications. Each vehicle carried an SCR-508 radio system that provided reliable communication up to 10 miles. This communication advantage allowed M18 platoons to coordinate complex maneuvers that appeared chaotic to German observers but followed carefully planned patterns. Lieutenant Colonel James Harrison, commanding the 704th Tank Destroyer Battalion, developed innovative communication protocols. We used coded position references, pre-planned movement sequences, and split-second timing. A single radio call could coordinate 4 M18s attacking from different directions simultaneously. The Germans never figured out our communication methods. German radio interception efforts proved largely unsuccessful. American frequency hopping techniques and coded communications kept German intelligence in the dark about M18 movements. Meanwhile, German radio discipline, weakened by combat stress and equipment failures, often provided American forces with valuable intelligence about Panzer unit positions and intentions. The M18's 76mm M1A1 gun, while not the largest caliber in American service, proved devastatingly effective against German armor when combined with superior tactics. The gun fired several ammunition types, each optimized for specific targets. M79 armor-piercing AP, designed for maximum penetration against heavy armor, capable of defeating Panther side armor at 1,000 yards. M62, armor-piercing capped ballistic. Capped AP-CBC, the most common round, balanced penetration and post-penetration effects. M88, high-velocity armor-piercing, HVAP, tungsten cord rounds that could penetrate Tiger I frontal armor at 500 yards. When available. M42, A1 high explosive. HE, devastating against infantry and soft-skinned vehicles. Master Sergeant William Thompson, 705th Tank Destroyer Battalion gunner, explained ammunition selection. We learned to carry mixed loads, mostly AP-CBC for general use, a few HVAP rounds for the really tough targets, and always some HE for infantry. The key was knowing which round to use and having it ready when the target appeared. The M18's hydraulic turret traverse allowed gunners to engage multiple targets rapidly with different ammunition types. This flexibility proved crucial when facing combined arms German formations, including tanks, assault guns, and infantry. Despite the M18's thin armor, crew survival rates remained surprisingly high due to several factors beyond pure speed. The open turret allowed rapid crew evacuation when vehicles were hit. The vehicle's automotive components created fewer deadly fragments than specialized tank components when penetrated. Captain Robert Morrison, 823rd Tank Destroyer Battalion medical officer, documented crew injury patterns. M18 crews suffered fewer fatal injuries than Sherman tank crews despite thinner armor. The open turret meant that blast effects vented upward rather than being contained inside the fighting compartment. Crews could bail out faster, and when they were wounded, we could reach them more quickly. The Tank Destroyer Force developed specialized medical evacuation procedures for M18 units. Fast Jeep ambulances could reach disabled M18s more quickly than the heavy recovery vehicles needed for conventional tanks. This rapid medical response saved lives that might have been lost with slower evacuation procedures. M18 units pioneered night combat techniques that exploited their speed and quiet operation. The right radial engine, while distinctive in sound, was actually quieter than many diesel engines when properly maintained. Skilled drivers learned to use terrain masking and engine management to approach German positions undetected. Staff Sergeant David Kim, 85th Tank Destroyer Battalion, specialized in night operations. We'd move at dawn or dusk when light conditions favored us. The M18's low silhouette was almost invisible in poor light. We could get within 200 yards of German positions before they detected us. First shot had to count. After that, speed was everything. Night operations required extensive crew training and coordination. Drivers learned to navigate using minimal lighting. Gunners practiced target acquisition in limited visibility, and commanders developed techniques for maintaining unit cohesion in darkness. The M18's automotive heritage simplified maintenance compared to purpose-built tank destroyers. Many components were interchangeable with standard Army vehicles, reducing spare parts requirements. The right radial engine, despite its aircraft origins, proved remarkably robust under field conditions. Technical Sergeant Michael O'Sullivan, 704th Tank Destroyer Battalion Maintenance Chief, managed a complex logistics operation. We kept parts cannibalized from damaged vehicles, maintained relationships with Air Force mechanics who understood the radial engine and learned to fabricate replacement parts in field workshops. The M18 was reliable, but when something broke, we had to be creative. The automatic transmission, while revolutionary, initially created maintenance challenges. Early production models suffered from transmission fluid leaks and pump failures. Field modifications and improved maintenance procedures eventually solved most problems, but crews learned to carry spare transmission fluid and basic hydraulic tools. Despite doctrine emphasizing open terrain operations, M18s occasionally fought in urban environments where their speed advantages were negated. These engagements revealed both weaknesses and unexpected strengths of the design. During fighting in Aachen, Sergeant Robert Chen's M18 crew developed urban tactics. In cities, speed meant nothing. There wasn't room to maneuver. But the M18's low profile let us hide behind rubble piles that wouldn't conceal a Sherman. The open turret let us engage targets above us that closed turret vehicles couldn't reach. Urban operations required different tactics. M18s worked closely with infantry, using their mobility to rapidly relocate between buildings rather than racing across open ground. The thin armor that was a liability in open combat sometimes proved advantageous in cities where over-penetration by German rounds reduced their effectiveness. M18 units often served as mobile reconnaissance platforms, using their speed to gather intelligence about German positions and movements. The vehicle's small size and high mobility made it ideal for reconnaissance missions that would be suicidal for heavier vehicles. Lieutenant Michael Rodriguez, 823rd Tank Destroyer Battalion intelligence officer, coordinated reconnaissance missions. We'd send an M18 forward to probe German positions, draw fire to identify enemy locations, then withdraw before they could. Coordinate effective responses. The information gathered in these missions often proved more valuable than tank kills. These reconnaissance missions provided crucial intelligence for larger operations. M18. Crews learned to identify German vehicle types by engine sounds, track patterns, and tactical formations. This intelligence allowed American commanders to plan counter-operations with detailed knowledge of enemy capabilities and positions. The mountainous terrain of the Italian peninsula created unique challenges and opportunities for M18 operations. The 85th Tank Destroyer Battalion's experience in the Apennine Mountains demonstrated the vehicle's adaptability to extreme terrain conditions. Technical Sergeant James Patterson described mountain operations. The mountains changed everything. Speed didn't matter when you're climbing a 30-degree slope, but the M18's power-to-weight ratio let us climb grades that stopped German armor cold. We could reach positions they thought were impossible, engage them from above, then disappear down the reverse slope. Mountain warfare emphasized different aspects of M18 capabilities. The vehicle's excellent power-to-weight ratio allowed operation at altitudes where heavier vehicles struggled with reduced engine performance. The low ground pressure prevented damage to narrow mountain roads that couldn't support heavier traffic. M18. Tactical doctrine evolved rapidly based on combat experience. The Tank Destroyer Training Center continuously updated training programs based on after-action reports from combat units. This feedback loop ensured that new crews learned from the experiences of veterans. Colonel Andrew Bruce, father of the tank destroyer concept, personally reviewed combat reports. Every engagement taught us something new. We updated training materials monthly, incorporating lessons learned at the cost of American blood. Crews arriving in Europe in 1945 were far better prepared than those who fought at Anzio in 1944. Advanced training courses developed specialized techniques for different combat environments. Desert warfare courses emphasized navigation and mechanical maintenance in extreme conditions. Winter warfare training focused on cold weather operations and snow mobility. Urban warfare instruction taught close-quarters combat techniques. As Allied forces crossed into Germany, M18 units faced increasingly desperate German resistance. The combination of experienced German defensive tactics and familiar terrain created new challenges for M18 operations. The 827th Tank Destroyer Battalion's assault crossing of the Rhine demonstrated M18 versatility in combined arms operations. Captain Robert Harrison described the crossing. "We loaded the M18s onto pontoon ferries under artillery fire, crossed the river and immediately engaged German armor on the far bank. Within minutes of landing, we'd destroyed 2 Panzer IVs and were advancing toward our objectives." The final months of the war saw M18 units adapting to new roles as German resistance collapsed. With few enemy tanks remaining, M18s served increasingly in infantry support roles, using their mobility to rapidly respond to German strongpoints and bypass resistance.